when you see a change in the code, it does not mean that the requirements change. 90% of changes in the code are not changes in requirements.
Hello and welcome to Sean White's Solar and Energy Storage Podcast. This podcast is on the 2023 National Electrical Code. Yep, that's right. We went into a time machine to figure this one out. We have Bill Brooks, who writes a lot of the National Electrical Code for renewable energy systems, live at Intersolar in 2022. This is part one of a three-part podcast. So that means you can come back for more. And so once again, this is a 2022 preview of what's going to be in the 2023 NEC with Bill Brooks, recorded at Intersolar in Long Beach, California. So a little bit about Bill, if you're not already familiar with Bill. He is instrumental in the process of coming up with the material for the National Electrical Code for renewable energy systems, especially for solar, energy storage, and interconnections. Although the 2023 NEC has not yet been finalized or published, this is the best preview that you can get as far as knowing what the future will bring. Many manufacturers, engineers, CEOs, and other decision makers can make better informed decisions about the future knowing what will be in the National Electrical Code. Bill Brooks is on code making panel number 4. They call that the Alternative Energy Panel sometimes, and has been perhaps the most active member of the PV Industry Forum, which is where new material for the NEC for solar PV, energy storage, and interconnections is made. Bill has been working on codes and standards for 34 years, at least. Bill Brooks and Sean White also published the book PV and the NEC. Stay tuned for the 2023 version of that one. So some of the things that we're going to talk about, I'm going to go over them really quick right now. NEC Article 100 definitions. And the big thing about the 2023 NEC is all the definitions now have moved to Article 100. We're going to talk about EPCs, as in electronic power converters, electronic transformers, inverter definitions, PV hazard control UL 3741, rapid shutdown, 690.4, 690.12, NEC 750 energy management systems, that's EMS, NEC 705.13 power control systems, PCS, net metering 3.0 protests, NEC 712 DC microgrids being removed for the NEC in 2023 because it is going into 705 interconnected power production sources, PV string circuits. Yep, that's right. We get to use the word string now in the NEC for the first time. Not like we haven't said string a million times anyway when we're talking about PV in series. Now it's official. PV output circuits have been removed from the NEC, just the term. PV system output circuit is what it's called. Recombiner, we're going to mention about recombiners, paralleling circuits and harnesses, first solar modules, PV source circuits going into and out of DC combiners. String circuit is series only, not parallel. DC to DC converter circuits, wild PV, PV system disconnects. 690.15 has been reorganized. Locking requirements, ground fault protection, ground fault detection and interruption, that's GFDI. That term is clarified, not to be confused with GFCI, ground fault circuit interrupter. 690.45 equipment grounding conductors, EGCs, includes DC and AC not having to increase size of the equipment grounding conductor when upsizing current carrying conductor for voltage drop. That also applies to AC. So let's get on with the podcast, and just a little shout out to check out my website, solarsean.com, where you can find all kinds of classes on this type of material, including classes that will get you NABCEP certified. On with the show.
All the definitions in the NEC, 100% went to Article 100. So normally in the past, most of them were in Article 100, but then we had specialized things that only were in certain articles that would be actually in a definition section, and it was always 690.2 or where we did definitions. They came up with this great idea, which will probably get changed in the future, where they said, okay, we're going to move all of the definitions in Article 100. So Article 100 used to be a couple pages long. Now it's like 30 pages long. Oh. It's the longest article in the code by far now. What they also did is they did core words. And so for searchability, so inverter is a core word. And so if we have an inverter input circuit, inverter output circuit, a multi-mode inverter, standalone inverter, interactive inverter, anything like that, inverter is the core word. So when you're looking at it, it's more like it's set up like an index. So it indexes the process, and it's made for digital searches, to make digital searches a lot easier. You type in multi-mode inverter, it'll still take you here, because it's in parens multi-mode inverter. But it's just an inverter. It's a special kind of inverter. By the way, this is a fun one. I did change these to inverter input circuit, inverter output circuit to conductors connected to the input, conductors connected to the output. I also changed this, equipment that changes DC to AC. We had a 3-sentence definition of an inverter, and half of it was wrong. And it's like, guys, why don't we just go with what super simple? It's just a device that takes DC and turns it into AC. I don't care how it does it. Don't tell me about the transistors or whether it's rotating or not. No. Just it's an inverter. Okay. If you want to talk about more than that, we want to talk electronic power conversion devices. Okay. So electric power conversion. Now that's another thing that we added.
So for a battery, are you still calling that an inverter because it goes both ways, DC to AC, AC to DC? By the way, I saw AC/DC right here in Long Beach a long time ago. That's why I can't hear so well.
Yeah. But they didn't do DC to AC. So.
So like for a battery inverter, it can do AC to DC. You still call it an inverter in the code? I know you...
No, that's not an... Just because an electronic power conversion device has the capability of going both ways, it doesn't mean it's inverting both directions. It might be, probably not. It's just when it's going from DC to AC, that by definition is inversion. So they were all called electronic power converters. Okay.
EPC.
Yeah, or static power converters. These were the terms that were used in the world. And so this was a shorthand. So it's a converter. It's converting DC to AC, but it's got what we call an unwrapper circuit in it. So most electronic power converters, a static power converter, what it'll do is it pulse width modulates, creates a half wave, all right? Because generally speaking, they don't do both sides of the wave. So they create the half waves, they create a bunch of humps, and they have an unwrapper circuit that inverts every other half wave. And that's how they got their name inverter. Okay? So it's to invert means to change the polarity of every other half wave. And that's where it gets its term. So, for fun, that's cocktail party knowledge. Electronic power conversion. Okay, so that's a device that uses power electronics. I also added this to the code. A device that uses power electronics to convert one form of electrical power into another form of electrical power. Super basic, okay? If it's electricity, and it starts in this side, and it's electricity getting out the other side, and it's using electronics to do it, it's an electronic power converter. DC to AC, AC to DC, DC to DC, AC to AC, if it's using electronics to do it. Now, a transformer is not an electronic power converter. A transformer is using magnetics to change the voltage from one voltage to another or to isolate two systems. So an electronic, but you can have an electronic transformation of voltage from one voltage to another. That is possible. There are electronic transformers, if you will. Fully electronic, no magnetics whatsoever. It is physically possible to do that. It's just probably not worth it in most cases. That's just some fun stuff there. You're going to have to get used to using the code differently now because of the way they've done this. I'm going to have to get used to using the code differently now because it's going to be a little frustrating if you're used to just flipping back to the beginning of 690. So, PV hazard control. This is the new UL standard, UL 3741. It was ratified about a year ago. It's been out on the market. There are very few products currently listed to UL 3741. We might see some at the show tomorrow. So be looking around. And UL 3741 PV hazard control, it is a method, as we'll talk about later, to comply with rapid shutdown. It's mentioned now in 690.4 and 690.12. And so if you have to look these things up, sometimes we're going to talk in shorthand like this. And forgive us if we do that. You can write it down, look it up. But 690.12, this is kind of like a joke by number. Whenever we say 690.12 or .12, we mean rapid shutdown. It's quicker than saying rapid shutdown. A lot of people hate the term rapid shutdown. I invented the term out of duress, not because I like it. And so anyway, we have that, but that's just so you know. And the joke by number, and we'll do the short version of this joke, but there's this joke club. Everybody gets together in this joke club. They tell jokes, and they have like a book of jokes. And so they've gotten so good at, they know these jokes so well, they just do them by number. And so somebody will stand up and go, 45. And everybody just die laughing. Just like instantly die laughing because they know what joke 45 is, and it brings it up in their brain. Somebody gets up and goes, 21. Everybody dies laughing. So this new guy comes. He wants to join the club. And he's looking through their book, and he's like, 16, that's a good one. He jumps up and says, 16. And nobody laughs. It's like, dude, it's a good joke. Somebody taps him on the shoulder and says, some people can't tell a joke. Anyway, so joke by number. So in the code, we got numbers all over the place, and we're going to tell you jokes by number, and it is what it is. Paragraphs with multiple requirements were put into lists throughout. So basically, we had from on high. The correlating committee said, if you've got more than one requirement in a paragraph, you got to turn it into a list. All right? It's been in the style manual of the code for probably decades, and we just kind of ignored it. And we just wrote our paragraphs the way we wanted to and said, whatever. And they said, no, we're actually going to tell you to do it. So, okay, fine. So there's lots of little changes in the code. You got to remember, when you see a change in the code, this is true everywhere, it does not mean that the requirements changed. Okay, really, really critically important thing. 90% of changes in the code are not changes in requirements. In fact, that's especially true in the 2023 code because it could be reorganizing, it could be doing all kinds of little things, or clarification, changing the language to make it more clear of what the original intent was. The intent didn't change. It's just a lot of people were having a tough time understanding what was intended, and they were misinterpreting it. Therefore, we go through and we do a code change to try to clarify. Now, the fact of the matter is we will never, ever make a code that will be clear to everyone. It's impossible. Codes are using text to try to convey fairly complex concepts to the public and to everyone else that uses the code. Because of that, there are always going to be people that use their own reason, and sometimes well and sometimes not so well, to interpret what they read. And those people may be in a position of authority that you can't do crap about it. Or your recourse is very small in what you can do to change their mind on that subject. That's the challenge, and that challenge will never go away. So if you want it to go away, live on another planet. It's not going to happen here. It's just, it's reality. If you think the world should be fair, that's great. It's just not going to happen. So get over it. So there are lots of changes, but not necessarily requirement changes. Energy management systems was unified with other articles of the code. So we had tried to make this statement in the last code cycle that we wanted to kind of team up with energy management systems because what we were doing was part of energy management. And the energy management people said, nah, we don't want to play with you guys. You're weird. So we said, okay, we're just going to call it power control systems. And you're going to hate that term so much. I invented that term. You're going to hate that term so much. You're going to come over to our side. And they did. So the good news was they came over to our side. The next thing was something that caused me a lot of heartache. There was a power grab by a utility organization that will remain nameless to move the control of interconnected systems out of CMP4. Code Making Panel 4 is the code panel. It's often referred to now as the alternative energy panel. It used to be the service section article of the code, and then we were shoved into their code panel. They didn't like us very much. And then we kind of won them over to our side, and now they were friends, and they say, oh, you guys are too friendly. So they took Article 230 and 225 out of our code panel and put it into code panel 10 because they were bored and they didn't have anything to do. Unfortunately, then this utility organization said, we don't like the way things are going. It was really one person. They're a consultant, and they wanted to make a bunch of trouble, and they did. And they wrote a whole new article, Article 231, to be interconnected systems. And they took Article 705 and they copied it, and then they changed a bunch of stuff. And it's like, holy crap, you can't do that. So I was the only one that made a presentation to the Code Panel 10 on this particular issue that said, you guys, I didn't say this, but they were out of the freaking minds. It's like, I made the point that because of what you saw earlier in Sean's presentation, Chapter 2 is revised by chapters 5 through 7, so you can write an entire article, cut and paste from chapter 7 into chapter 2, and it has no impact on the code whatsoever. Because anything that's different, so they made a bunch of changes, anything that's different is modified by chapter 7 automatically, without any discussion. It's not like I like chapter 2 more than I like chapter 7. This is the way the NEC has been written. And so I made that plea to a group of people that are very intelligent, and they voted 100%. I got one person to abstain to do this Article 231, which is a complete violation of how the code's set up. So, people vote stupid sometimes. Let's just put it that way and move on. So, fortunately, the correlating committee, whose job is to keep track of all this stuff, said, time out, guys, you can't do that. And so they set up a task group. They didn't invite me to the task group because I would have been just too belligerent, I guess, probably. And the task group basically made everybody sit back down, and they stopped doing what they did. They changed a few things in Article 705, and the guy got his paycheck, and everybody was happy. But there's politics. So what I'm telling you right now is that there are lots of politics that go on in the code-making process. Why is that? Because there's lots of money that's involved here, folks. And if you think that code process is somehow immune to that kind of influence, you're a little bit naive. It's just the way it is. And so we have things that we have to do to fight for stuff. And, maybe we have some financial stake in what goes on. And if somebody wants to change something that's going to financially impact us negatively, we're going to fight about it. We're going to talk about it. They may have the right idea, but we're not going to just roll over and say, oh, yeah, that's great. Let's do that. Because we have to look at all the implications that go into this. I've been doing this for 34 years. I've been beating my head against the wall on codes and standards for 34 years. There is always a new challenge. There's always something new coming up. There's always something that's going to change. And we have net metering 3.0, which isn't net metering. These things will go on forever. Anybody here from a utility? I mean, just because you're from a utility doesn't mean you agree with net metering 3.0, but it's just silly. I mean, just come on, give me a break. Now, there's no question that net metering was an incentive to the solar industry for decades, for sure. There was no doubt about that. And it was intended to be so. The pendulum swung way too far in the other direction. So hopefully, people will get their brain and kind of bring it a little back to center, and things will move on without just crazy stuff going on, but we don't know. They're going to have a little thing tomorrow, right?
Protest.
So protest. Go out there and give them hell.
Burn your PG&E bills.
That's right.
I think there's utility control going on.
That's what it is. Okay. Anyway, so we got through that crap just to tell you that that stuff happens. There's lots of unenforceable references to maintenance in the NEC now. This just absolutely aggravate the crap out of me. We kept it out of CNP4 stuff. We fought it out. It is a play by some of the unions. I work with unions all the time, so I'm not going to badmouth unions at all. But there's some union people that believe that this is a way for them to, get the upper hand on whatever the heck they want to get the upper hand on. Again, because they're trying to preserve their jobs or whatever they're doing. And it's just BS. And they're putting maintenance requirements into a construction code. It's like, come on, people. I mean, sure, okay, you can put it in there. You're just making yourself look stupid. That's all. Just don't do it. And people have been rolling over on that issue. It's like, don't you know what this code's for? So it's very concerning that that's happened, and we just said, no, not going to happen. Article 712 was for DC microgrids, and that was established several code cycles ago, and we said, okay, yeah, there might be a reason. There was a big company that was into DC microgrids. They wanted their own article, and we said, okay, I guess maybe that should be a thing. And so then it went in, and it's like, this thing's not really well written. I know the guy who wrote it, and it's like, this is kind of sketchy. And then we started thinking about it, and it's like, you know what? We're connecting DC stuff all the time in Article 705. And if we have to go to 712 and deal with all this other crap in 712, this is not necessarily a good thing. So 705 is not interconnected AC power systems, it's interconnected systems. And so we said, listen, let's go ahead and see if we can get Article 712 out of the code. And we did. Now, if you're interconnecting any power sources whatsoever, It's going to happen in 705 where it should have. All right, Sean's going to love this slide because we got PV string circuits into the National Electrical Code. This is going to save like 5 or 10 minutes of him going off on the fact that the NEC didn't have
out of a
string.
job now.
Yeah. It's like, when we get to that slide, just move on. Okay, Sean? So,
But you have square cells. You should put rounded corners on them now.
yeah. Anyway, so we do have string circuits. The reason we did this is that I wanted to get the term PV output circuit out of the code. Why is that? Because we've been talking about output circuits in Article 705 a lot. So we've got ESS output circuits, we got PV output circuits, we got wind output circuits, we got all kinds of output circuits. And a PV system output circuit, so something that's coming out of a PV system, PV output circuit should be something that's clean and clear and is coming out of a PV system, so we can use these terms kind of parallel to one another. And so when we had this PV output circuit, it had to do with, okay, we were combining stuff together, and then we were coming out of that combining to another thing, and then we called that an output circuit, and then people wanted to call this another combiner a recombiner. That term just drives me up the wall. Recombine. How do you recombine something? I'm sorry. It's like I'm making a cake here, and I put all this stuff together, and then what am I going to do? Take it all apart and then recombine it back together again? What the heck? But everybody knows what it means, and after a while I just give up and say, okay, everybody knows what I mean when I buy recombiner, so fine. I'm a words person, and it's just the words have to make sense to me, otherwise it just drives me up the wall. Because that's the way the code's written. The code is all about getting the words right. I still want to find the person that invented the term recombiner. I haven't found him yet. I'm going to shoot him. But I'm not going to shoot him, but I'm just going to have a chat with him. And so...
You're going to recombine them.
Yeah.
So, take them apart, his individual molecules, and then put them back together.
That's right. So anyway, we got rid of that term, and now we just have PV source circuits. Okay, PV source circuits, they can have multiple circuits connected together. A PV string circuit is a single string of modules. Okay, a PV string circuit can also be a source circuit. Okay, a source circuit might be a string circuit. They're not necessarily even with each other. Most people are used to putting modules together in series and going to a fuse or going to an inverter. And that's still how we do things for the vast majority. But for decades before you guys came along, we would we'd put together parallel circuits before we go to fusing and things like that. And if you worked for First Solar or anything like that, First Solar have been paralleling circuits and harnesses and stuff like that for over a decade. So we have these circuits that are PV source circuits that might include parallel and series circuits, and they're all sources. They're a source circuit, okay? But the string circuit within a First Solar system would be the group of 6 or 8 or 10 modules of First Solar modules that would be in series with one another. And they might go to a fuse in the harness, or they might not, depending on the design of the harness. Okay? So just so you're aware, those terms did change in the 2023 code. It is more consistent with how we work, but the term PV output circuit just is going away, disappearing.
So in that drawing, it says PV source circuit coming out of a combiner, is it?
Correct. Yeah. So now what comes out of the combiner, it cannot be a string circuit at that point, right? Because once you parallel two things, it's a series parallel arrangement. A string circuit is a series arrangement. Does that make sense? Okay. And everybody better know what everything else is in that picture.
No more PV output circuits?
No more PV output circuits. Moving on. So we could have a source or a string circuit coming up to, so we could have modules in series, we could have a single module going to a DC converter, we could have multiple modules going to a DC converter, but once we get to the converter, we're no longer a PV circuit, okay? It's not a PV string circuit or a PV source circuit. The output of a DC to DC converter is a DC to DC converter circuit, okay? It is an electronic power converter. It has converted whatever you were doing before. It no longer has the attributes of a photovoltaic circuit. So, okay, we could call it smart PV and dumb PV. We can call it wild PV. I like to call it wild PV over here. This is wild PV over here. And then we have controlled PV. Uncontrolled, controlled. Okay? When we control something, it means that we have control over it. So we now can interpret it and change the characteristics of that any way we want. All right? And that's why SolarEdge can put 100 modules on a circuit. 100 modules on a circuit. Now they got multiple modules going to a converter, things like that, because it's not a string circuit. It's not a PV source circuit. It's a DC to DC converter circuit. We can do whatever we want with that circuit within the confines of the capabilities of that circuit.
Thanks for listening to Sean White's Solar and Energy Storage Podcast. That was part 1 of a 2023 National Electrical Code preview with Bill Brooks. Stay tuned for parts 2 and 3 and go to solarsean.com to find out more about everything and to take some of my heat spring classes. Thanks. Over and out.